Now rectilinear motion with constant acceleration. Sometimes we assume this case like if the acceleration is constant. So in which case we can assume constant acceleration. For example, if we imagine the case of free falling bodies, for example, if you throw a ball upward, so when the ball move upward, it will force I mean it will experience a force from the downward direction due to its weight, and as a result of that force of attraction, there will be the change in velocity of that ball. Change in velocity means when you throw it upward, initially its velocity will be more, and then as it moves upward, there will be a constant change in velocity, and then change in velocity will be definitely uh, the reduction in velocity. So initially, if its velocity is, for example, 100, then it will be reduced. Then again, when it's moving, so every second there will be change in velocity. That change in velocity is basically due to the gravitational field, and that is in that case it is equal to minus 9.81 meter per second square. Similarly, if you are having a ball and if you throw it from upward, up out means from top floor without applying any force, and the only force that it's having, it is basically due to its weight. So earth will attract that ball toward its center or toward its surface with the force of gravitation, and the velocity of ball will increase at every second, and the increase in velocity again it will be 9.81 meter per second square. Mean the change in velocity, it will be 9.81 meter per second. So that is basically the case of constant acceleration. So usually in case of free falling bodies, we consider it as a constant acceleration case. Okay, whatever I have said, so it will be better if I explain it with some diagram. So in coming lectures, sorry, in coming slides, I will explain the same thing again with a proper diagram, so you will be able to understand it. Okay, so again, the three basic kinematic equations will be used, but remember, in this case, we are imagining a constant acceleration case. That is rectilinear motion with constant acceleration. Okay, so we are having this equation, we are having this equation, we are having this equation. And if you remember, we had equation of motions in our physics course. Equation of motion याद है ना आपको? जी, did you people derive equation of motions?
Yes, sir.
Okay, what was those equation of motion? कितनी equations of motions थे हमारे पास?
Sir, 3 थी.
Okay, anyone who means एक equation के बारे में अगर कोई बताना चाहे, any of the equation if you remember.
VF square, VF is equal to VI plus AT.
Okay, this was one of the equation. So basically with constant acceleration case, we want to derive those equation. So now let's see. Okay, so constant acceleration means that we will be having acceleration is equal to a constant, this one. Okay, so when acceleration is constant, this means the change in velocity is constant, right? Means, for example, the change in velocity, if it is 2, so it will remain 2. Means 2 meter per second, the acceleration will be 2 meter per second square. It will remain 2 meter per second square. It will not be changed. So in that case, the velocity will remain v naught and the displacement will also remain s naught. Okay, so a is equal to dv by dt. This is like the basic equation, and from here we can write dv is equal to a dt. As to find out this acceleration, what we can do, we can basically take derivative of velocity, and if we if basically we move the dt on this side, so we can get this equation. But in this case, we are having a constant acceleration, so we can put this value over here as c dt. So take integral of this one. This one will become v. The limits will be v naught dv, and over here this is constant. This acceleration is constant, so we can take this out of the integral, and the only thing that we will get over here, that will be dt. So when we take the integral, this one will become v minus v naught, and on this side what we will get, ac into t, right? So this is basically v minus v naught is equal to ac plus t. This is negative sign. If we move to the right, of the of this equality sign. So what we will get? We will get V is equal to V naught plus ACT. So this is the same equation which you just discussed, or which you just told, which is Vf is equal to Vi plus At. So this is basically the same equation. So this V is basically the final velocity, this is the initial velocity, this is that constant acceleration case, and this is the time. Okay, so this is one of the equation. So V is equal to V naught plus At. We will use this equation in our problems. Now let's look at the other one. We need to find out one for, this one was for velocity. Now we need to find out one for the position also. Okay, so as we know that acceleration is constant, so the velocity will be V naught and the displacement will be S naught. Okay, so V is equal to ds by dt. What we need to find out? We need to find out something for ds. Okay, so ds is equal to V dt, and we have this equation V naught plus ACT, V naught plus ACT. Okay, so when you put integral for ds, it will be S naught, and for this one it will be from time interval t is equal to 0 to any time t. Okay, and this value. Now V naught, if we take integral of this one will become V naught t, and when you take integral of this one, this is like constant, this is constant, so this one will become t square by 2. So when you put the when you take the integral and put the limits, so you get s minus s naught V naught t, and the other one is 0, so this term will be eliminated automatically, and 1 by 2 ACT square. So when you arrange this equation, so s will become s naught plus V naught t plus half AT square. So this is the same equation which we used to pronounce, which we used in our physics course, that was s is equal to VIT plus half AT square. So in this case, that s on the left side, that is basically the displacement, which is the change in position, s minus s naught. Okay, so in this case, instead of displacement, we have write the change in position, which is s minus s naught. S naught is on the right side, so s naught plus V naught t plus half AT square. This is the second equation. Now let's derive another equation, which is the third equation of motion. Again, we are having the constant acceleration case, so we can use this third equation. We use this one, we use this one, and by using this third equation, basic kinematic equation, we can derive another one, A ds v dv. So A can be constant. Okay, and for vdv, what we can do, basically we can put the limits. So put limits on this one, s naught v naught. So s naught, when you, this is constant, so when you take it out, the only integral that you will get, it is basically for a constant, and since we are taking integral with respect to ds, so what we will get s, and the limit will be s naught. So when you put the value, we will get s minus s naught, and over here when you try to find out integral of v with respect to dv, so this one will become v square by 2, and when you put the limit, so half v square minus v naught square. Okay, now when you arrange this thing, so what we will get, basically take this 2 on this side. Okay, so this one will become 2ac s minus s naught, and over here basically what we get, we will get v square minus v naught square. So when you move this v naught to this side, so again it will become positive. So by rearranging the equation, what we will get v square is equal to v naught square plus 2a s minus s naught. So this can be like the third equation of motion that we used to have, which was basically vf square minus vi square is equal to 2as. So again, that 2as was delta s, that was basically displacement, and in this case we know that displacement is basically equal to change in position. So this is the same equation. So if you are having problem in memorizing this one, so you can relate this equation with the basic physical equation which you already memorized. So based on this, you can write this equation, and even if you cannot memorize, it's not that much difficult. You just need to memorize this equation, and from these equation you can derive anything. You can derive this equation of motion. Okay, so remember that these equations were useful when we consider the acceleration as constant, and in first two cases we took the initial time as 0. Okay, so as I have told you, a typical example of constant acceleration motion, uh, when it can occur when a body falls freely towards the earth. So if we neglect the air resistance and the distance of fall, if we imagine it is short, it is not out of like our gravitational field, then in that case, the downward acceleration of body when it is close to the earth, it is basically approximately 9.81 meter per second square, or 32.2 feet per second square, which is basically the gravitational acceleration. So the constant acceleration example can be like free falling bodies. Okay, so now uh, whatever I was explaining, it can be again better explained with the help of this example. A ball was thrown straight up in the air from 1.2 meter above the ground. So initially imagine that the person who was throwing the ball, he was at a distance of 1.2 meter above the ground. So the initial position of person is 1.2 meter from the ground. After 3 seconds, the ball returned to the ground. After 3 seconds, the ball does not return to this position, it returned to the ground, means it returned to zero elevation. Okay, so the initial level, it is basically this one. So at this instant, initially, let's say this is the time is t naught, displacement, the position is s naught, and the velocity is v naught, and the s naught is basically equal to 1.2 meter. Okay, so the person has thrown the ball upward, and then it reaches this ground. So the time taken by this whole process, it is basically how much? It is 3 seconds. So after 3 seconds, the ball returned to the ground. So when the ball, let's say if this is 1, then this position, let it be 2. So let's say this is the position 2. So now at this instant, T2 is basically 3 seconds. We have this value now. S2, how much is S2? S2 is 0. Okay? Okay. Now what we need to do, we need to find out, determine the maximum height it reached. So what is the maximum height? This is basically, initially a person was standing over here and ball was also at this position. So the maximum height will be this one. We need to find out S1. We need to find out this S1. So how we can find it out? Let's see. Okay. So initially, when the person throw the ball upward, like you can see over here, when the person throw the ball upward, so it was having some velocity, and definitely the velocity was more, means initially the velocity was more, but at it moves upward, like you can see, when the person threw the ball, initially it was having greater velocity. It moves after some time, the velocity decreases further. As it moves, the velocity decreases again, the velocity decreases, and at this point the velocity becomes 0. Are you getting this point?
Yes, sir.
Yes, sir.
Okay, now in this case there is change in velocity, the change in velocity between these 2 points, right? Then again the change in velocity between these 2 points, the change in velocity between these 2 points, change in velocity between these 2 points, right? Why there is change in velocity?
Because there is deceleration.
Why
Velocity
there is
is
deceleration?
changing.
Why deceleration?
because of gravity.
Because of gravity. Very good. And the value of gravity is how much? Acceleration due to gravity is how much?
9.8.
9.8.
Okay, so this change in velocity, it will be 9.81. This change in velocity will be 9.81. This change in velocity will be 9.81. This change in velocity will be 9.81. So up till this point, we are having deceleration. And now after this zero velocity, again, the velocity will increase, right? And as it moved onward, the velocity will increase more, and then more, and then, so now again we are having change in velocity, right? How much will be the change in velocity in this case?
Same.
9.2.
How much?
9.8.
Positive 9.8.
Exactly. So this is basically like free falling body case. Okay, so it should be realized that the ball is subjected to a deceleration from position 0 to position 1 of 9.81 meter per second square, and then from position 1 to position 2 it is accelerated at the same rate. Further, even though the ball momentarily come to rest at position 1 when v1 was 0, the acceleration at 1 is still 9.81 meter per second square. At that instant there was that change velocity, due to which the change was means from 9.81 velocity it becomes 0 velocity, let's say. So there was still that change, and then after that instant again the velocity increases. So when the acceleration at that instant it was 9.81 meter per second square, so that is the case of constant acceleration. So what we need to do, basically we need to find out the position. So t naught was 0. At t naught was 0, when t naught was 0, the position where the ball was, or where the person was standing, it was 1.2 meter, and at that instant we didn't know at which velocity he thrown the ball, that initial velocity. Okay, at t1, what was the time? We don't know again the time at which it reached the maximum height. Then at that instant the height which the ball attained, or the maximum height, we need to find out that one. But we know that at that maximum height, what was the velocity? The velocity was basically 0, because when ball reached till this position, at that position the velocity becomes 0, and then the velocity start increasing. Okay, but we know that the acceleration is basically 9.81 meter per second square. Okay, when the ground reaches when the ball reaches the ground, at that instant the time was basically 3 seconds, and the elevation was basically 0, and at that instant the velocity, the final velocity with which the ball hit the ground, again it is unknown. Okay, so what is required in the question? That is basically S1. Okay, so are you people getting that how I am finding these boundary conditions? कैसे मैं ये data निकाल रहा हूँ? समझ आ रही है सबको?
Yes, sir.
Okay, so now we are having, for constant acceleration we just derive few equations, and these equations are basically given over here. That is S is equal to S naught plus V naught t plus half at square, V is equal to V naught plus et, and then again V square is equal to V naught plus 2ac S minus S naught. Remember, I can apply this equation between state 0 and state 2. I can apply this equation between state 1 and state 2. I can apply this equation between state 0 and state 2. It depends. So but if you apply equation from 1 to 2, so the values in this whole, it will be between 1 and 2, not 1 and 0, or not mix up. Okay, okay, so again, like we are having these values. So for example, what I need to find out, basically I need to find out the distance S1. So you need to look at that whether I can find out this distance directly or not. So I have this T naught, which is 0. I have S naught, and I don't have V naught. Okay, so can I find out this V naught? So I need to look at this equation. What is the value of S, the maximum height? I don't know, but I know this S naught, which was basically 1.2, and if I, which S is known, this 1.2 and this one. So if I put this equation between 0 and 2, these two are known, right? This one.
Your cursor is not visible, sir.
Okay, now this one, right? Okay, like you see, in this equation, I have this S, I have this S, right? Two terms are known. Okay.
Yes, sir.
Okay, so if this is, so what I can do means this one and this one. I can apply this equation between 0 and 2, from 0 to 2. Can I apply this equation? So from this equation, what I will get? From this equation, basically, okay, t is also given, right? So in this equation, we have this t, and we will be having this t. So what I will get? I will basically get v naught. From this equation, I can get v naught, right?
Yes, sir.
Okay, so let's do it this way. So let it be 2, this one not, and acceleration is constant, and final time is basically 3 seconds. So let it be 2, this one, this one also 2, this one also 2. So when I use this equation, as I have told you, okay, put this s2 is equal to 0. Okay, s naught is equal to how much? 1.2.
1.2.
Okay, v naught is not given. V naught, let's see, it is given or not. It is not given. Okay, t2 is 3. So put it over here. Acceleration is constant. Free falling body is 9.81 due to gravity, and this is t. So from here we have find it out v naught. Now we have v naught, and now, okay, what we need to find out now? Okay, what we need to find? We basically need to find out this s,
V or S.
right? This is like the final answer. We are doing everything for this one. So if I use this equation, I can find it out. Even if I use this equation, still I can find out, right? How? Let's see. Do we have v1? We have
Yes,
v1, right?
Yes, sir.
Do we have v naught?
Yes, sir.
Do we have a?
Yes, sir.
And what about s naught? Do we have s naught?
Yes, sir.
If this is
1.2.
if this is v1, this is v1. So this one will become s1, right?
Yes, sir.
Okay, so we can find out this s1 from here. Okay, let's s1. If this one become s1, we already have s naught, right? है ना हमारे पास s naught?
yes, sir. जी है.
Yes, sir.
Okay, we also have v naught. V naught है हमारे पास.
जी.
Okay, do we have t1 हमारे पास है?
नहीं सर, T1 नहीं है.
t1 नहीं है. इस इक्वेशन को बस इसी को यूज करें फिर. ठीक है.
जी.
Okay, so let's do it this way. So this one will become v1 square and v naught square 2ac s1 minus s naught. When you put value and you solve it, so you can get this thing. Okay, now I get s1 also. So from here I can find out t1 from this equation if needed. It is basically not needed in this question, but now I can find out t1. So in exam, if for example if they ask you to find out t1, you can also do it from this one then. Is that clear?
Yes, sir.
Okay, so this is like the answer. Okay, now let's look at another example. Again, this is from R.C. Hibbeler book. During a test, a rocket travel upward at 75 meters per second. Rocket is traveling upward at how much speed, how much velocity?
75 meters per second.
75 meters. So this means this is the initial velocity, right? Means from the very first statement, from the very first word, it's very difficult like to imagine something. But from initial statement, let's say it be the initial velocity. पूरा स्टेटमेंट पढ़ने के बाद हो सकता है अगर हमारी इमेजिनेशन गलत हो तो हम इसको चेंज कर सकते हैं. Okay, so during a test rocket travel upward at 75 meters per second, and when it is 40 meters from ground, when it is 40 meter from ground, its engine fails, right? इसका मतलब क्या है? इसका मतलब ये है कि हमारे पास एक रॉकेट है, वो जमीन से ऊपर की तरफ जा रहा है। स्पीड क्या है उसकी?
75 मीटर पर सेकेंड।
75 मीटर पर सेकेंड। ओके, सडनली उसका इंजन फेल हो जाता है। तो जब इंजन फेल हो जाता है, वो डायरेक्टली वहीं से नीचे गिरेगा, यानी ये थोड़ा सा ऊपर जाएगा?
थोड़ा सा ऊपर जाएगा सर, इनर्शिया की
थोड़ा
वजह
सा
से।
ऊपर
ठीक है,
जाएगा।
ठीक है, एग्जैक्टली वो मोमेंटम की वजह से वो ऊपर आपके पास वो कंटिन्यू करेगा थोड़ा सा, ठीक है। सो नाउ when it is 40 meter from the ground, its engine fail, आपने क्या करना है? Determine the maximum height SP. What you need to find out? You need to find out the maximum height which it attained and its speed just before it hits the ground, और वो speed जब वो ground को hit करें। Okay, so let's say initial condition when during a test when it is 40 meter, आपके पास क्या speed थी? At this level when we were having how much height? 40 meter. At that instant हमारे पास velocity कितनी थी?
75 मीटर पर सेकेंड।
75 meter per second. It was moving with the constant velocity 75 meter per second, right?
यस सर।
Okay. At point A, engine fails. Engine fails. This means 75 meter per second velocity तो नहीं रहेगी, velocity ने कम होना,
जी।
ठीक है। और ये कम जो होगी किस वजह से? फोर्स ऑफ ग्रेविटेशन की वजह से।
ग्रेविटी की वजह से।
ओके, सो फ्रॉम नाउ ऑनवर्ड यहाँ पे जो डिसेलरेशन होगी, चेंज इन वेलोसिटी होगी, दैट विल बी हाउ मच? 9.81।
9.81।
ओके, सो दिस एक्सेलरेशन विल रिमेन कांस्टेंट हियर, एंड ये हाइट आपने बेसिकली फाइंड आउट करनी है, ये वाली। एंड देन फ्रॉम हियर व्हेन इट मूव्स बैक, सो अगेन कौन सी एक्सेलरेशन होगी?
ग्रेविटी की
9
एक्सेलरेशन
9 पॉइंट, ठीक है। तो यहाँ पे फाइनली जब इस पोजीशन पे ये पहुंचेगा, सो यहाँ पे इसकी वेलोसिटी क्या होगी वो आपने फाइंड आउट करनी है, ठीक है। So it should be realized that the rocket is subjected to deceleration from A to B, from this A to B of 9.81, and then from B to C again, from B to C. So it is having how much acceleration and change in velocity? That is 9.81. Furthermore, even though the rocket momentarily come to rest at B, same case जो कि अभी थोड़ी देर पहले मैंने एक्सप्लेन किया कि इवन अगर इस पोजीशन पे रेस्ट पे भी आ गया, स्टिल भी आपके पास यहाँ पे वेलोसिटी तो जीरो हो जाएगी, लेकिन स्टिल एक्सेलरेशन जो इस पॉइंट पे है वो 9.81 ही होगी। एक्सेलरेशन एट बी इज स्टिल 9.81 मीटर पर सेकंड स्क्वायर। ओके, सो लेट्स से वेलोसिटी एट ए, पॉइंट बी पे वेलोसिटी क्या हो जाएगी? जीरो हो जाएगी ना, velocity at B, and then acceleration, ठीक है, वो आपके पास 9.81 है। Okay, what we need to find out? We need to find out VC and we need to find out SB, ठीक है। यही चीजें हमने करनी है ना। Do we have SA? SA हमारे पास है।
जी सर है।
अच्छा, और हमारे पास इनिशियल वेलोसिटी भी है, राइट?
जी।
ओके, सो हमारे पास इनिशियल वेलोसिटी भी है, हमारे पास अगर इनिशियल वेलोसिटी हमारे पास है और हमारे पास इमेजिन करें पॉइंट ए और बी के दरमियान, पहले देखते हैं पॉइंट ए और बी के दरमियान ये दो चीजें हमारे पास है, वेलोसिटी दोनों पॉइंट्स पे है, फाइनल वेलोसिटी, इनिशियल वेलोसिटी, वी आल्सो हैव एक्सेलरेशन। व्हाट वी नीड टू फाइंड आउट? वी जस्ट नीड टू फाइंड आउट एस बी, और हमारे पास इनिशियल एस ए भी है, राइट?
जी सर।
ओके, सो हमने क्या फाइंड आउट करना है? हमने सिर्फ एस बी फाइंड आउट करना है। we have initial final velocity, we have acceleration, we have initial position, we need final position. Okay, ये है हमारे पास ना।
जी।
अच्छा, ये अगर हमारे इसमें टी का मसला आ जाएगा ना, टी टी कैन कॉज
सर
इशू।
थर्ड इक्वेशन अगर यूज करें
थर्ड,
तो
ओके,
आसानी
लेट ठीक है, चले थर्ड पे देखते हैं। डू वी हैव दिस वन? वी भी हो जाएगा ना ये।
यस सर।
डू वी हैव दिस वन? वी ए हो जाएगा ये।
G.
Okay. Do we have A
Yes, sir. Acceleration due to gravity.
or do we have SB?
सर एक एस है एक नहीं है.
ठीक है, SA. So there is one unknown. What is the unknown? Is SB, right? And this is asked in the question. यही तो question में पूछा गया कि आप find out करें. Determine the maximum height SB, right?
Yes, sir.
Okay, this one. Okay, the maximum height SB. So from here we can find out. I think it's simple maths now, right?
Yes, sir.
Okay, put these values and you can find out SB. Is it clear?
G,
Is
sir.
it clear? Okay, now let's see what else they want. Okay, now they want basically what else they are asking? Find out VC, right? So now see, now we have this VB and we have we want to find out VC, right? Okay, now we have SB. Do we have SB?
Yes, sir. We have SB.
And what about SC? Do we have SC?
Yes, sir. We also have SC by adding
Okay.
SA and SB.
Okay, so what we need to find out? We need to find out only one velocity. So which equation should we use? Again, same. Can we use this equation between B and C? We have BB, right? We need to find out
Yes, sir.
VC, right? We have SC, we have SB,
SB, yes, sir.
right? We
Yes,
also
sir.
have acceleration.
Yes, sir.
So from this equation, can we find out VC?
Definitely.
Okay, so let's see. Okay, here. Okay. So when you put all those values, what you will get VC is equal to minus 80.1, 80.1. So here you can find out this one. Is it clear?
Yes, sir.
Okay. So this is basically your answer. So you can find out the velocity by using this equation. Okay. Is there any question in this problem? Okay, silence. So
No.
this means no problem. Okay. So let's see what we assume over here. Why is acceleration due to gravity negative? What do you think? Why it is negative? Because acceleration due to gravity means the pull is towards the earth, right? So when an object when it moves up, what we usually do, we usually assume the velocity and everything in upward direction is positive, but acceleration due to gravity, it is downward, so that's why it is negative, right? So if up is positive and gravity points down, then acceleration due to gravity would be downward, so it will have negative magnitude, whether the upward direction will be taken as positive and downward direction as negative, or vice versa. So it simply depends on you. If you take the convention as downward as positive, so then acceleration due to gravity will be positive, right?
Yes,
So
sir.
for example, when you do how we can say, like let me give you another example. For example, when you throw ball upward, so initially its velocity is 10. So as it's moved upward, there is some pull. So due to that pull, the velocity changes. Again, the velocity changes. Again, as it moves upward, with every second, the velocity changes. So you see the change in velocity between these 2 points is how much? Between these two, 10 minus 8, 2, right? What about this one? 8 minus 6, 2. What about this one? 6 minus 4,
2 again.
2 again. So again 2. Again, here now the velocity is 0. But how much is the acceleration? How much is change in velocity?
It will also be 0.
Oh, No, it will not be 0. The velocity will be 0, but the change in acceleration is 2. The change in velocity is 2. Like, for example, 2 change here, 2 change here. So change in velocity is acceleration. So acceleration is 2 here, 2 here, 2 here, 2 here,
Yes,
2
sir.
here.
The change in
So
velocity,
now
yes,
when it's
the
0,
change
yes. So for the next second, again the velocity will be 2,
two.
right? For the next second, it will be 4. So this is like the case of constant acceleration. So you can means take it this way. Okay, so important points from previous lecture as well as from today. So Hibbler book, what they do, they basically conclude at the end of every topic. They make some conclusive remarks. So dynamics is concerned with bodies that have accelerated motion, right? We define it like in last class. I defined that sometimes we define it as the mechanics of accelerated bodies, if you remember. Then kinematics is the study of geometry of motion. Geometry means displacement, velocity, acceleration, etc. Kinetics is the study of the forces that causes the motion. Then rectilinear kinematics refers to straight line motion. Speed refers to the magnitude of velocity. Average speed is the total distance traveled divided by the total time. This is different from the average velocity, which is displacement divided by the time. And a particle that is slowing down, this means the acceleration will be negative. It is also known as deceleration or decelerating. The body is decelerating. A particle can have acceleration and yet have zero velocity, right? We saw this case so many times in our lecture today. The relationship AdS is equal to VD. How it is derived? It is derived from these two equations. A is equal to dV by dt. And this equation is derived from this one and this one by eliminating, by taking dt out from this one.